All right, we're live here, starting in a minute. I'm just going to give folks time to come on into the room and all like that. I didn't plan on any background music this time for some reason. We can fix it in post. See you in a sec. Hey, and welcome back. We are live, and we just got the little test print off the printer, making sure our settings are all good to go. Oh, gotta tell you, that doesn't look so great right there, but luckily, I don't know, we may have to do some adjustments there. That's a bit of a messy sidewall. We'll do some adjustments before we print our piece. But today we're starting off, we've got this broken locket. We got the point here where it broke off is just a little too tiny to get soldered back on in any way that's going to stay. So I'm going to try and design and print a little hat on here using FreeCAD. And then while that prints, we will... That's the one. Hey, I managed to stop at the same place. We'll draw this one up in FreeCAD based on the old technical drawing book from my college days. Over on the side here, you see all the various designs I've done in FreeCAD 0.21 version, so we're going to stick with it for now. And let's just, let's see, make sure everything's good to go. Looks good. Looks good there. All right, so let's get on to it here. Here we are in FreeCAD. We're going to start by making a model or partial model of the actual locket, and then we'll add on to it. We're going to start creating a new design, create a new body, create a new sketch. And since this is kind of front view, we're actually going to build it from the bottom up. We could do it in a number of different ways. We could build it from the bottom up like that. We could mid profile and revolve it. And maybe we'll do the revolve. So we'll go to the front plane and let's get some measurements with our trusty calipers. So the first thing we want to know is how tall is it? So we get a measurement here. Oh, it's all nice and backwards in the camera, isn't it? Lovely. Anyway, 33.5 is not a critical dimension, but we'll go with that. 33.5. And we'll start as that as the middle. We're going to come out some like that. Go up some like that. Go back over. Up some. Back to the center line, and from the center line down. And that's our basic shape, right? I don't think that point is actually on the center line, so let's click those two and say attach a point to the object. Oh, I guess it was. Burned orange, which means that it's over constrained, meaning I have one too many constraints. The object on point on line was one too many because this is a vertical line and it ties into this point, so it's already automatically lined up for us. So let's get, we figured this dimension here was 33. Grab that line, dimension it, make it 33. Well, that's clearly not that tall, is it? It's more like about there. So let's see what it is tall altogether. And actually, we really just want this dimension here, just this top nub. So we're just going to get it roughly there. Let's see if I get my eyes crossed just so. Out there. 4.6. We'll go with 4.5. We want it to, actually, no, we'll stick with 4.6. And that's that distance here. 4.6. Now, obviously, it doesn't look like those dimensions are quite right. I mean, we obviously know the height dimensions are correct, but it looks a little fat, doesn't it? So we're going to shrink these up and get these main dimensions. Main dimension there. 6.73. And we want a little clearance there, so we'll call it 6.8. That might be too much. 6.73, 6.76. We'll go with that. And since that's the diameter and we only need half of it for this radius, this will be set to 6.76, but divided by 2, since we're doing radius, not diameter. And you can see as we've fully defined, as we manage to fully define, or in this case, what they refer to as fully constrain the lines, they go from blue, or from white to green. And the white lines are ones that can still move. They haven't been restricted in their movement size. But they are restricted being vertical or horizontal or point on this line. And in this case, we have both the horizontal and the vertical. So we've got this one distance left here from here to there. This line down here needs to be defined, and let's go ahead and take that measurement. We want this to be closer to the actual edge. So we'll measure just about there. This is 12.14. It's probably closer to 12. Yeah, we'll just call it 12. And that's 12 over 2, or 6. And so that looks more like our proportions, right? We can close that sketch. Say we want to revolve that object, and there we go. There's our basic shape of this particular object. I mean, obviously this has all sorts of decoration and various other jewels on it and so forth, but we're not really worried about those for now. We do have this kind of rounded over dome to the top of it. And so we're going to represent that, although probably not be completely accurate with its exact dimension, with a fillet. And a fillet of 1 millimeter, that looks more or less right, maybe 2. All right, we'll go with 2. Yeah, it's almost a complete dome. Maybe not quite. Let's redo that. More like 1.5. Yeah, that's closer to it. So that's our current object. Now we want to create another body, which is the actual connector on top. And there's a number of different shapes we could go with. I want to make it a little bit taller because we do have to get the end of the chain through it. So it needs to be tall enough to have the opening wide enough for the chain to get through, although this is a pretty small chain. So it won't have to be too big. So now that's our existing body. We'll create a new body. Create a new sketch. I'm going to base it on this plane. And then right now we want Let's see, what do we want to do? It'd be nice if we could project the existing items onto this body. Let's see. I think this projects now. It doesn't project across bodies, which is one of the strange limitations of FreeCAD. From one body to the next, it doesn't project it. I believe they have a different concept for that. I haven't gotten that far into those features, mostly just building single body objects. But we have our dimensions, so we can always go back to our sketch and get our dimensions. Oops. Other body sketch. Sorry about that. There we go. Get all of our dimensions back. So basically we got 4.6, 6, and 3.4. So we want it to be a little larger so it sits on top. So 3.4 and 4.6 and 6 all together. All right. So let's draw what we want. Well, first, well, how do we want to do this? Maybe we do it from above and then we can taper it. Yeah, let's do that instead. Because the bonus of doing it from above is that we already have the home dimension, the origin to work with. And yes, that's the very barky dog. Alright. Go from the top. I want to put the whole thing, circle. From here to there, we're going to give it a diameter of 12. And that's just the way it goes, right? Live stream is live with puppies and all. So we're going to take this and really we want to make it, what was that dimension? 33, right? So we're going to close that. And right now our sketch is down at the bottom of our object. I really would rather it be up here. So let's see if we can do that. Probably the easiest way is just go into the attachment editor and change the offset. There we go. Take it up here all the way to 33, was it? Yeah, there we go. Say okay. And now we're going to pad that circle up just a bit. How much do we want to pad that circle? Let's see. We want to be past that. Let's see if we do it about to there-ish. That's about 14. All right. So let's go ahead and pad that. Make it 14. And we have that as a separate body now. Now we're going to do a couple of things with it. We want to maybe trim it off a little and make a hole for it. So let's look at the front. Go ahead and make a sketch along that plane. You can now see the insides of it. And we want to, let's see. We'll start with projecting the top and bottom edges of the of this cylinder, and then we're going to say we want to kind of about like that. Or do we, well, let's make it a little more decorative. Why not? Make it up parallel or vertical to there. And then from there, we'll trim it off to there. And go ahead and throw in some dimensions just so we can get our sketch constraint. That was conveniently 6. We get an angle on this. The angle constraint. Well, maybe make it 160. No, wanted to go the other way. Instead of 160, we'll go 150. There we go. We'll have a little bit of on here to round off later. So now what we want to do is take this profile and sort of cut it out. What we'll do is we're going to do a subtractive groove, they call it. And to do that, you know, I'm not really digging on it being this short. I maybe want to add another bit to it and make that top a little taller. So before we go any further, let's go back into the pad, make this 20. That'll be a little bit taller. Now if we go back into the sketch, you'll see our projected geometry and our attached lines have maintained their position, but 150 is way too much angle now because we want to be a little bit here in the center. So we'll make it 175. Oh, way too much. 160 then. Way too little. 165 in the middle. There we go. That's a good angle for it. Now let's just finish off our little cookie cutter, if you will. Draw lines around. I'll go ahead and make that a horizontal line for convenience. Now, we could stop here. We don't have to define these things. It doesn't have to be fully constrained, but it's generally good practice. So we'll pick a dimension, 7.11. It can be 7. There we go. And then this dimension, we'll just make that 2. And there we are. Now we're fully constrained. We close this, take a look back at this angle. You'll see that's our sort of cookie cutter shape. And now we're going to use this subtractive groove tool to rotate this profile all the way around and chop away. There we go. That's kind of what I wanted. Not exactly though. But that's okay. We can keep working on it. See what else we want to do. Let's see, just at the front. I think I want to sort of cut those off flattish, at least near the top, and then we'll give it some curvature in a minute. So let's go ahead and we're going to use this plane again and project this top edge. And really, yeah, I kind of want it to be flattish. We're going to make a line that comes down well, you know, we'll make it like that. Now that I think about it, I really didn't want to do a groove. Let's delete the groove. Yes. Complaints because of dependent items. Go back into this sketch. And instead of being a groove, let's just cut across it in both ways. So we'll just do regular pocket or subtraction, make it symmetric and through both sides, and that's more what I was looking for. And of course, I don't want it just on one side, right? I want it on both sides. So we're going to take this pocket and mirror it. There we go. Now I got it on both sides. That's more what I'm looking for. And then I think these two edges, we round them off or fillet them. Let's chamfer them and see what it looks like. Maybe 3mm? Yeah, that's good. That's more or less what I was looking for. And then we're going to have sort of a oval shape here, which is the hole through the middle. Another sketch. So in previous CAD packages, I would do a lot of sketches, sort of master sketch, and select the profiles I want to either extrude or make holes with. And in FreeCAD, it's really best to keep one feature per sketch. I've learned over the time in using it. In fact, we'll go ahead and we can actually use this slot tool. Create the hole we want. And just project that line from the bottom. Or from the top. And then we can get a dimension from there to there of, dimension from that point to that point. 4.22, we'll round it off to 4. And then for the diameter of this, which also defines the width of the thing, it says 3. We'll go ahead and make that 4. Well, maybe not. We don't want to weaken it too much, right? This area here is where all the stresses are going to be. I should highlight here. This area here is where the chain's going to go through and provide all the stress. So we want that to be relatively beefy. So I think also I can get away with, grab that dimension so we can see it. We can probably get away with, let's see, if we turn this on and reduce it to dimension we're about to use, 4. You know, that 4, that's a pretty good gap, especially for this size of chain, right? So that chain can easily fit through a much smaller gap. You can easily fit through a 2mm gap. So we'll use 2 so as to leave as much meat on the bone, as it were. And then we have to figure out the height that we want to do here. This 5 point some odd. We'll make it a rounded 5. There we go. So that's going to be our slot. We close. Make a pocket. We're going to do through all and symmetric. And there we go. There's our nice little hole through. And to maybe make it a little bit easier to get the thread through and out, in and out, let's go ahead and chamfer that hole. And chamfer of 1 looks good. Now we could either chamfer this other hole while we're at it, or we could mirror the feature. Either way. I guess it's easy enough to go ahead and say select and grab the next one. There we go. And that's about as complicated as I need that part to be. No point in making it more complicated than it needs to be, right? But you'll notice that if we hide the first part, our bottom is solid. We need that hole in there for it to fit into. So rather than recut the hole, if you will, actually, I should say, we could either recut the hole or we could subtract the 2 bodies. But subtracting the bodies leaves no tolerance, no clearance. So I think we will go ahead and subtract the hole, redraw it as it were. We can grab that surface create a sketch. And luckily it's a simple circle, but I forget what diameter we're dealing with, so let's go ahead and remeasure it just for accuracy's sake. We measured it's 6.78, 6.8. So let's make it 7 diameter, and that should be enough for clearance. Diameter constraint 7. Nose. Now we're going to punch that hole in there, make a hole, right? And it's 5 deep. I think it's plenty deep for this. Yeah, that should give us all the clearance across all that. In fact, 4.5 would probably be plenty. So let's go ahead and make that hole just 4.5. And same kind of thing, we're going to set this on top of here, right? We're going to sort of insert it there, if you will. So to ease that insertion, we're going to create a chamfer on that edge. And 1 is probably way too much considering the scale, so we'll go 1.5. So there's our top part, our top piece rather. Looks like a reasonable enough design to start with. We'll print it off, see how well it holds, see how well it fits. So now that we have our body 1, let's go ahead and rename that. We'll call this Locket top, for lack of a better term. And since that's the active object, we can file, export. We haven't saved the file, so it calls it unnamed, but Locket top.stl. Go ahead and save the file itself. All right, so there's our little object, all ready to print. Should look pretty interesting in this silver PLA. We'll have some nice little facet shines and so forth. It'd be somewhat similar to the shininess of the Locket itself. So now we've saved that object off. We need to transfer that object STL file. Is down here. Locket top STL and transfer that over to the desktop of the Windows machine. Since our Windows machine is where all of our 3D printer software works. And that is over here. There we go. Let's see. Looks like I'll do a quick stream check. Everything looks like it's doing good. All right, go back to the model. Get rid of our test piece, and there's Locket top in its actual size. It's really small. Because sometimes you have problems printing things that are this small. And let's see, we don't really want it to be printed like this at this angle because all of the layers are horizontal, right? And if there's going to be a snap in the 3D printed part, it's typically along the layer lines. So really we want to sort of rotate this piece around and print it where this face is flat down. So depending on the sophistication of the tool that you have, let's see. There we go. We can just kind of rotate it around a bit. Like that, roughly there. And I think if we go ahead and the position and land it, go ahead and look at it from behind. And that's not quite flat on the print bed. Let's see, was it 100, was it? You can kind of see once it starts rocking, right? There we go. 105. Looks like the degree to be. There we go. And what this will do is it will print with the layer lines horizontal, and that will create loops. I keep hitting the wrong key there. It'll create loops of plastic like this, and that'll be a lot stronger. So let's see if we can go ahead and get that sliced. Printer takes its time to come together. Sliced it again. Our print in place. We got all our settings all ready to go. I'm going to go ahead and bump up the infill because it's a really small part, and it could be closer to completely infilled. It'd probably be a little safer. And let's see, supports. We're going to go ahead and print a brim around it that helps hold it down to the print bed, and low supports, so there may be some underneath those. So let's go ahead and say print, which does the slicing. Do a preview. There we go. So there you get the chance to see ahead of time where the support has been added inside the hole and around that edge. And then you have this concentric sort of rings of plastic, and that should be a lot stronger. The downside to that is that our layer lines are now sort of not quite vertical to the piece when it's done, and so there's a chance if this hole is not opened up enough that it will sort of snap. But we'll give it a shot and see what it looks like. Now we say print again. Oh, well, while we're in the preview mode, let's go ahead and look at the look at the print information. It thinks it'll take all of 15 minutes and 53 seconds to print, which is good because that's about what time I was imagining. Now we'll go ahead and print. Print. It's now sending it to the printer, or it's going to fail out because it likes to do that, especially when I'm trying to live stream something. So print again. There we go. That time I got it. And it really shouldn't take all that much time to transmit, and then it's going to start heating up and printing that along, and it should be done pretty quick. So now that is all we need to do with the printer. So let's go ahead and minimize that view again. And let's start on our other project, right? That's our Locket top, and our other project was this item that was found in my old 3D printing book, or not 3D printing, my technical drawing, hand drawing book from college. And I've brought in this image, gone ahead and angled it such that it's readily readable while we continue to work on the piece. And let's do a quick stream check. Doing good. Yeah. All right. Now let's start to figure out how we want to divvy this up, right? So a lot of folks would just start with the base, and that's probably a decent place to start. Or we could start looking at it on this face, just where it is. Draw these circles first and use this as the origin. And but then you'll see this actually sticks out a little bit further from this other piece. So if we take the piece and we sort of go on this plane and then expand it in this direction with the extrude, or pad as they say in FreeCAD, then we'll sort of end up doing it in 2 steps, if you will. The first one, just to get this thickness here, which isn't even drawn. And what they're showing is they show radius 17. So since this is no other dimension given, it's presumed to be this radius 17 goes from so that the radius 17 is right there. So let's go ahead and we'll start from that sort of front view. And let's see, we got this big circle is 41, and it is 38 from the bottom. But that's really all we need to start off with, is that circle, that dimension. We'll go with that. So we're going to go to a front view, sketch. So first off, we need to create a body. Then we're going to create a sketch. We want it to be this front view. Get rid of that. You'll see the rest of our image. Seems like we're a little bit further away from it than we need to be. Like, let's go ahead and close and go back to our reference figure. Transform and drag it over here a little bit. There we go. Now back to our sketch. Got a 41 diameter circle there. Big circle. Diameter 41. Oh, geez. We're really scaled, aren't we? All right. So one of the things we can do to sort of bring them closer together is in this reference figure, we can do a calibrate on the reference figure. And essentially say from here to there is supposed to be 41. There we go, nice and shrunk down for us. Then we take our reference figure again. We're going to transform it some more. We want it to stand up and move over there so that when we're in this position, our reference figure and our object are going to end up looking roughly the same. And there we go. Good transform. All right, now we can go back to our sketch. And that was 41. Sketch is hard to see now, but 41, and then it was 38 from the center down to the bottom of this. (41, 38). So let's go ahead and start with a polyline. Our sketch is going to be essentially from the center of this downward, vertical. It's going to go over, and go up again, and go over like that some. And I just realized that, remembering some of the limitations here. Let's go ahead and close this here. So this rounded shape, in some tool packages, you could get that full rounded shape by using a fillet that was equal sides. In this package, if you fillet equal sides to the point, in other words, if you start off with this, we start off with this being square, right? And then we try and fillet these two edges, right? So we start off square like that, and then we fillet these two edges, and we try and make it all the way around like this, where we essentially destroy this plane. The FreeCAD underlying engine will complain. So it's easier to make this kind of shape from the top up and extrude it. So we're going to shift gears and do that real quick. So clear that off. Oh. Back to the sketch. Go ahead and we can keep the sketch for now. We'll create a new sketch. Create a new sketch from looking down on top. All right. And if we pop back over to here to be able to read it, let's see, what dimensions do we need? We've got 76 from this part to this part, and then radius 17 around here. So 17 and 76. Hey, that's convenient. Let's go ahead and I think we can actually draw a slot. All right, we'll draw a slot from here along here. Distance between, well, it really doesn't like trying to grab the points, does it? I'm making it easy on myself and just grab this line instead. So that distance is 76. And this radius, a constrain radius, is 17. And that is going to be a thickness of just this first part, the 16. All right, close that. Add that. Add it to 16. And the way I like to approach these is do all of the additive, where you're adding blocks on top, adding bits to it rather, first, and then do the subtractions. In fact, we really probably don't even need this other half of the circle here, although it's all going to be enveloped by, well, is it going to be enveloped by that circle? Let's see. Not quite. Oh yeah, it should be. Oh, I see what I did there. I extruded upwards. And by extruding upwards, I didn't keep the reference to this line here. So this line here is also this line here, right? If we had a side view of this. So let's go ahead and change that extrusion to reversed. There we go. And then take a front view of it and see when we extrude this cylinder, we're going to have a little excess here. We don't need that excess. So let's go back to that sketch in the pad and draw a line across here. And then we can actually take this arc and just say that arc edge is now construction geometry. We close, the re-extrude happens, and we're not interfering with our circular part there. Now let's go back to that original sketch that we had where we had our circle. Obviously these distances are incorrect. It's going to be more of a like that. We actually don't need that line there. So it's going to be kind of like that, right? Take a look. it is, the distance from here down to there is 38 from the center. So from this center spot, again, hard to grab when you're not looking directly at it. This spot to this spot is 38. Right? That's what it said. Let's see. Luckily, we can zoom in on the diagram as well. Yes, 38 to there, and then 51 to this foot. So this length here is 51. And let's see. We can actually project this bottom edge. If it'll let me select it. That bottom edge, that's the one I want. We want that point to be on that line. There we go. Now we're fully green, we're fully constrained. Although we're not what they refer to as the wire is not closed. Which is to say that we don't have a closed shape here. We have this closed shape and this sort of dangling U shape. Move the dimensions out of the way and you can see it better. This sort of dangling U shape here. So to polish that off, let's draw a line from here. So we can just log from here to there. And then use the trim tool to trim off the excess. Oh, missing a piece. Sometimes those two colors overlapping is kind of confusing. Actually, no, that wasn't it. We want to trim that line away. There we go. So it says we have 1 degree of freedom left, which means we're not fully constrained, and there it is. That line needs to be considered horizontal. Now we're fully green again, and we're one solid shape. Go ahead and close. And we want to extrude that shape, or pad, as they say. And we're going to do it symmetric. And instead of to a dimension, we say to first. Oh, up to face. Select a face. There. Interesting. Doesn't let us do that symmetrically. Yeah, that's okay. We can pad it again. Basically just take the same sketch. Do pad a second time. Again, do first, but reversed. There we go. That gives us the basic shape. This is 38 from there to there. This 38 looks a little warped, if you will. That's what it says, 38 and 51. We definitely did those dimensions. We can double check them though. There they are, 38, 51. But they claim. Looks a lot different in the drawing than here, but sometimes I wonder if they intentionally distorted the proportions here so that you couldn't sort of reference the drawing. You had to use the dimensions. Wouldn't surprise me. So now you'll notice there's one other detail here. We've got this slot detail underneath that we need to handle. So let's handle that. It's 9 and then 16 and you know, probably centered. Probably. So we want to make that notch And I don't think that notch is going to interfere with this. We can go ahead and make that notch now, even though it's a subtractive feature. But, well, maybe let's go ahead and finish the additive features first. So one of the additive features was that this sticks out a little further on both sides. And conveniently, that's an easy enough sketch, easy enough sketch to make. I'll go ahead and go with that split there. We want to import this dimension. And when we draw a circle, there we go. Easy enough. We're going to pad that again. Also symmetric. And this time we're going to use this 44 dimension. There we go. Now we've got that look. That's working pretty good. And then it's a little hard to tell, but this area here is raised up. This surface is raised up above this area by 3, right? And so it's a 25 millimeter boss that is well, it's 76, right? We already determined that it's concentric with the outer radius. We're going to do a 25 there, and that's going to raise up a little bit, just 3. So to do that, we're going to grab that plane, do a sketch on that plane, import the exterior shape that already exists, give ourselves a circle, which is a diameter of 25. Then we're going to pad that, total of 3 mils. There we go. So we've got that. Now we're ready for subtractive features. And the first subtractive feature I want to do is, let's do this slot on the bottom like we were planning. 9 and 16. Grab that surface. Draw a sketch. 9 and 16 it said, huh? It's going to be a rectangle that's roughly in there. Go ahead and project this edge. From here to here is a dimension of 9. And this all together is a dimension of 16. And let's go ahead and project and measure it anyway, but I suspect that here to here is also 9, yeah. So, and then, oh, we forgot to get the height of the thing, didn't we? Let's go ahead and look back at the height. It is 6 tall. We can go back over here and actually just grab that. Let's see, it is 6. Whoops. Leapt off the page, as it were. Project that line from the original geometry, get this point and that line. Say point is on line, and we're fully constrained. Go ahead and close the sketch. And we'll do a little light view under here and say pocket. Pocket through all. And there you go. Now we've got our slot there. We got our next couple of subtractive items. We got this hole here, the hole in the boss, and the hole through the big section. So we can do these two holes at the same time. They are diameter 11. One here and that one there. They're 41 mils apart. All right. Let's do a sketch. Plane. Go ahead and project in the circle. They were 11 millimeters there, and somewhere over here. These two holes are going to be equal in size. Then they are going to be a diameter of 11. And this and this were 41 apart. There we go. I keep saying there we go. There we go a lot. Go ahead and pocket. Through all symmetric to get it up the up that 3 millimeter boss. There's our two holes. We're almost completely done. A couple of more things to do. We need this hole through the middle, which it actually gives us two numbers. And these two numbers are tolerance. You know, it shouldn't be bigger than 22.23. It shouldn't be smaller than 22.17. 22.2 then. Or, yeah, 22.2. Again, create a sketch. There we want the sketch. 22.2 we said, right? A circle. 22.2. Right, close. Make a pocket with that sketch. Through all and symmetric. So it goes through both directions. There you go. Looking good so far. There we go. Now that we've got all the additive features, then the subtractive features, now we're going to do all of the 3D fillets and rounds and the like. It mentions here the fillets and rounds are all R3, but you also notice that this dimension is 3. So much like the problem where we can't fillet this smoothly, if we apply a, we'll just show you. If we apply a fillet of 3, go ahead and say okay there. If we apply a fillet there, we go from 1, 2, 3. It breaks. And we get error messages down below behind the camera here. And again, that's because it's just not quite there. Now you can estimate it just if you're doing it just for visual references, you can do 2.99 and that'll come pretty close, right? But that's not exactly the 3 millimeter fillet we were looking for. Let's go ahead and kill that fillet. And instead we're going to do this with a revolve. So again, a sketch along this plane. And we're going to head and project in that line and that line. And we're going to, we could draw an arc, but it's almost easier to draw a circle. Right? This circle got a diameter of 6, gives us a radius of 3. This point is on this circle. And this circle is tangent to that line. Right? So that gives us the baseline parts. Now if we use the polyline, we can fill in the gap, if you will. Between here and here, go up to here. Go ahead and make this one vertical. And there we go. Once we trim this, we'll see exactly where that line needs to be, right? Now, these 2 points need to be the same point, concentric, or coincident. Now, the rest of this shape doesn't matter all that much because it's all going to be embedded in there. We just have to make sure we're not so big that we're going to take in, fill in part of our hole there. And we could completely constrain it if we wanted to. Grab that line, round it to 1, round it to 2. This line, round it to 5. This line, round it to 4. And there, we're fully constrained. And now this is going to want to revolve around this axis. We don't really want that. We want it to revolve around the center line here. So to have it revolve around the center line here, we go ahead and create a construction line. And say that is construction geometry. Now when we close out and we do the additive revolve, you see it picked that main center line, which is not exactly what we want. We go with construction line 1, and that's what we want. So now that's a true 3mm fillet around that area without breaking the rendering engine, if you will. All right, say okay to that. Let's see. We got that hole there. We got all those other holes. Now all we need are the rest of these fillets. And they're all 3. So that should be pretty straightforward. We want to do a fillet. 3. The select mode. Those lines. That line there. Sometimes it's a little hard to find all of them. That line there. That surface, that line. There we go. So is that all of them? That looks like all of them. It doesn't really show whether it's filleted on that other side. Oh, wait. That vertical line has got a fillet on it. And so will this other vertical line. There we go. Let's see, did it not like that? Interesting. That's a pretty destructive fillet there. Let's see. I have to select. Deselect that one. Wow. Well, that's an interesting side effect, eh? I'm not quite sure what caused it to do that. Interesting. Well, I'm assuming it might be this edge. And probably this edge too. Let's see, preview there. No. Wow, that is really strange. Well, let's take off this edge. And that edge. It's just this top round part here that's filleted. Well, that is really strange. Well, I hope the FreeCAD folks are watching. Are you good FreeCAD folks watching? Because that's a really odd side effect. I never would have imagined that being a problem. Let's start getting rid of edges. And, okay, we got the one edge. Which it went all the way around. It must be projecting those edges, or following the whole edge. Interesting that it completely destroyed that whole section, though. All right, well, so we're going to cancel the fillet. So much for that fillet, eh? How can we make up for that fillet? See, sometimes if we do a different operation first, different things happen. Let's do just those two edges. And we fillet those without the odd side effect. No, actually we get the failed to create fillet error. Interesting, interesting, interesting. Wow. I was not expecting that. Let's see. If we remove those, we try filleting the back edge here. Right, just those two back edges. Shape is invalid. All right, so much for the fillet technique. We're going to have to do our subtractive fillet technique, if you will. So look at this from the bottom. We're going to project in these lines. Well, not that one. That don't matter. Those two lines and these two lines. And to do the subtractive fillet technique, are we going to even be able to do it? We're not sure we'll be able to do it because of this curvature here. I think we can come pretty close though. Again, easier often to do a circle. Let's just try it on one to begin with, rather than fighting it all together. There's 6. This and this are tangent. This and that are tangent. Right. And then we rim off that part. And then we polyline, point to point, point. So that kind of gives us our fillet, right? Move it all the way up to there. Oh, FreeCAD, you're funny sometimes. Well, that's pretty close to the fillet, isn't it? .5, and we cut into our surface. Odd, 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 odd. Well, this might be one of those times where we have to do the fillets first and then add our circle. Right? That is just odd, I gotta say. There we go. Get rid of those two. Yeah, let's just go ahead and add our fillets like we did before and re-add our donut part. Hate to have to reproduce work, but if that's what makes it behave, that's what makes it behave, right? Fillet of 3 along that line. Select, yes. Preview. Wow. Really odd. Look at that. Hole through the surface. All sorts of brokenness. Continue selecting. Just intentionally select all the ones that we actually want. There we go. Give it a shot. Failed to create. Preview. Failed. Yeah, because it's all busted. Alright. Well, so we don't get the fillets. Right? Big, well, it failed to create them because of the circle, right? So if we yeah, let's just take out the circle. We're going to subtract off our circle. First off, let's project the sizes of them. Actually, I only need the bigger one, right? So there's our circle. We're going to make that as a whole. Make it through all. Oh, FreeCAD. Oh, FreeCAD. You just really want to mess with me, don't you? Why? Why did you do that, Mr. FreeCAD? Freaky CAD. 2 first. Not any better. Up to face. This other face. Not any better. Sometimes the behavior is not well defined. Well, if it doesn't like taking it off after the fact, let's just not add it to begin with. Let's go ahead and delete that. Let's see. Was it this pad? No. This pad? Yeah. So let's delete that pad. And unfortunately that causes a reference break in the sketch. Undo for now. Give it a shot in, go ahead and open this up in the FreeCAD version 1 pre-release and see if that does any better. Save off figure 2 and leave out a 21. Let's see, it was here, downloads. And this is FreeCAD release candidate 2 of version 1. See if that has any problems or lesser problems. Yes. Recompute documents. All right. And a slightly different change in the color scheme and such for this one because it's just off the shelf. Let's see if we have any troubles with the sketch 3 and sketch 2 we can hide. Let's see if we have any more trouble with the fillet on this. So this line, we want to fill it. Interesting. In English. Hate that it's in English. Edit. Preferences. Standard. All right. Fill it. It's still in English. Restart it again. Here we go. Figure 2. Pick that line. Fill it. Now, we can still specify our units. We just have to say 3 millimeter to be exact about it. All right. Well, okay. Strangenesses. All the strangenesses. Okay, well, we got our fillet. Yes. Go back into the fillet. Select some additional lines. See where it breaks. Well, that still has our lines there. Like I said, that seems to have all the fillet lines we want. Zoom back around here. Select that additional line and that additional line. And preview. And okay. And it command not done. So brep API, that's the actual API it's using internally. I have no idea why this is a problem for it. Hmm. Really odd kind of an error to have, huh? Oh, seems to have had an error with that last fillet, or the fillets on the other side. What you gonna do? What you gonna do when the silly is you? Hmm. Well, we're just gonna finish it without the fillets, I guess. Fillet, you go away. And we're just gonna call that close enough. Because I have no idea why the fillets would behave that way. Again, hopefully, FreeCAD folks, if you're watching, you have a suggestion as to why that might be happening. I'm more than willing to send you the file, and you can maybe work through that, perhaps. Anyway, we're going to call that close enough on that one. And let's go see how our print is done. I don't remember hearing the beep beep beep. So I don't think it's finished. Let's see. Printer status. The print bid has been reset. Well, that kind of sounds like maybe it's done. Let's go take a look. Hang on one sec. So that was print bed version. This printed version. Say I'm not particularly happy about the print result. Pretty messy. Why that happens is print is going really low. That ends up concentrating too much heat. Okay, knock the print heat down. Nice and clear. Work material. Oh. There's a couple of ways you can do to deal with that kind of concentrated print spot. The easiest is to provide a sacrificial alternate item that gets printed along with this, so that the print head doesn't spend all its time in that one circle concentrating the heat going like this, and instead it drops a layer, then goes over here, drops a layer on something else. That sometimes will help clean that up. Doesn't look like the because of that as well. This bottom part does not quite look circular, does it? See if it comes anywhere near fitting. Oh, that no. Right. Well, I think we know where our problems are. Concentrated heat. So go ahead and additional. You can have two of the items. Maybe that's the best idea. Two of the items. Well, you can try printing it upright like that. And then we'll still have the problem of heat concentration as the here and the fact that separation line. But hopefully that would be enough. Not have to worry about it. And if we print two of them on the print bed at the same time, then separate that. Let's do that. It'll take twice as long to print, but okay. Model. Oh. Oh, not. Sliders to separate them. Oops. There. Apart. That should prevent there being much concentrated heat on the tops. Printing them this, all of the support will be on the bottom. We'll see. Should be a much cleaner print anyway. Separate. All off, but let's make it 50. Let's closer to the front of the printer. All right. Getting those. Come on. Crashed. Oh, what fun. Considering that the company is no longer with us. To get any support on that. What's worse? Open source that has bugs? Oh. That's what I get for not being connected, huh? Hopefully you were able to hear some of that. There we go. Back to the lapel mic. So as I was saying, screwed up print. Screwed up print much? All right, let's go ahead and drop our Locket top again. And we will clone them. And that was at -150. Oh, not -150, just 150. And then 0. Again, not 0, 100. There we are. Go ahead and print. Load our settings again. Nozzle temp is 210. Maybe that's a contributor to this messed up part. But I think with having the two parts separate, the print head will have, move between them, and that'll give the layers time to cool off in between. So print that. Preview. Yep, 35 minutes now. All right. Go ahead and get that printing ahead and going. And we'll try a different drawing. And we'll see if its fillets and rounds causes FreeCAD to go off into the weeds or not. Thanks for sticking with me, folks. I know I probably should have made sure it'd be all worked ahead of time, but that's not live streaming, is it? That's restreaming something you did live once. So let's go ahead and take a look here. Actually, I guess that's what I can do here. Just minimize that. And we are. Let's see, we've been going an hour and a half. Wow. Just a half hour more, and hopefully we'll have something clean off the printer. So let's go ahead and try a different item off of the collection and see if we can't get it to behave. I'll go back over to here. Go ahead and start up FreeCAD again. Create a new document. File, open. Signs. I don't know what you're gonna do. This one, maybe this one. See what that one is. It's the same one. Of course it is. Oh, interesting. Control Z doesn't get rid of it. All right, let's try the next one then. There we go. That's an interesting one. A little more complicated. It still has some fillets and so forth. Got some detail to it. Let's go ahead and give that one a shot. So we're going to do the same thing. I kind of like this perspective view. So let's transform our drawing position to be flat when we're in this perspective view. And we're going to move it away from the center a little bit. And we're going to make sure it's reasonably scaled. So calibrate. This distance here is supposed to be 76 millimeter. There we go. Now, interestingly, if we do the calibration, now we got to transform it again. We lose our transform. And then, like I said, let's transform it away from our center line. Okay, let's start with this base part right here. That's 76 by 125 and has a couple of slots in it. It's all pretty straightforward. 76 by 125, all right. Let's start a sketch looking down from on top. We're going to use a centered rectangle. Center it on the origin. This dimension was 125. And this dimension was 76. Close out. And that's pretty close together. Might transform this a little bit closer over here. And a little bit down. That way they're just closer together all together. Somewhat like that. All right. Now, the sketch, it is 19 in height, so we pad the sketch to 19. And then this is one of those times when you can, like I said, I tend to do all the additive features first and then the subtractive features. But when the slot is all the way through and it's part of the lower plate, we can just include those slots as we do the plate. So the slot is 10 wide. It's 2133, and it's a little hard to see where size is of it. But over here you see 13 for the width of this, and we're going to assume that they're the same. They're the same. Yeah, let's just presume they're the same. So 13 wide, 2133. All right. Cancel that. On the same pad sketch. And do a slot. It's somewhere here. It's a vertical slot. Between here and here is actually a dimension of 10. It's centered along this axis. So let's make that symmetric. And then it was 21 this way and 33 that way to the center holes. Right? And that was pretty close, 21. And then there to there was 33. Hey, works out because it was already symmetric. We don't need that dimension, but we do need the dimension that says that it is 13 across. That look right? There we go. There's our slot already in our plate. Looks correct. We got the 10, the 33, 21, 13 across. All right. Now, a couple other ways we can handle the slot. We can mirror the slot feature itself, or we could just add the slot to the sketch, the second slot to the sketch. Let's go ahead and grab all of those. Select the center line. Select mirror. And it's always interesting to me how it mirrored this dimension, but it didn't mirror any of the others. Like, right? So, like this and this, or vertical. And then, well, this line here all together didn't mirror that dimension for some reason. That's 10. 13. From here to there should be the 21, yes. And then why does it think it can still move? We haven't constrained that, so actually let's just make that and that dot horizontal. There we go. Now we're fully constrained. You can see dimension soup here, dimension and constraint soup. It's a little hard to see everything. In fact, rather than using dimensions repetitively like that, it's easier to say that line and that line are equal. And that way there's one less dimension on screen. A little bit clearer. Same kind of thing with this. We don't need a 13 for the diameter. And we can say this and this are equal. Now, why when we mirrored it didn't make them equal, I don't know. That's another FreeCADism. So when we close out, now we have both of our slots. And that's good. So now we want to make this post. this post here. So that post is apparently 50 by 29, and it is 48 from this front edge. 50, 29, and 48. 50 by 29 and 48. We're going to go ahead and create a new sketch. Again on the base plane. It is, well, let's see if it is actually a centered rectangle, if it's on that center. Certainly seems like it's on it. All right. This dimension was 50. This dimension was 29. And if we project this edge off of what we already did, distance from here to here, ooh, 48. Interesting. It wasn't actually 48, was it? Go ahead and take a look. Oh, it was 48. All right. Well, then, yeah, we're good. We're good to go. And we want this to come up at least where it intersects this circle, right? So to the center of the circle should be fine. So we can take this 95 number from the base up to the center of the clamp. And so we'll go ahead and pad that sketch to 95. That's looking pretty reasonable. Now we need to add this big boss circle. So to add that circle, we are going to first make the whole thing and then make the hole in the middle. Make the hole before the hole. And it is 82. So sketch along this plane. And because we made this 95 tall, that's our center point, right? So we draw there, or project there rather, our circle. That dot is on that object, and that dot is also on that object. And then the diameter is 82. And there we go. Close out that. Now we've got our center diameter there. What's this width here? It's 48. 48, right? And, but 22 in this dimension. So it's only 22 in one direction. It's not symmetric across the pole there. Because we also see this dimension of 8, that this sticks out 8 from the wall there. So 2248, right? And that is from the center line. So we will pad this, but it's going to be 2 dimensions. In one dimension, it's going to be 22. And in the other dimension, it's going to be 48 minus 22, which conveniently we can just put in as the math. There we go, 48 minus the 22. And that's our big boss, our big clamp part. Now let's draw the hole through our clamp part, shall we? Actually, let's draw this part on top first. And this part on top is 41 from the center line of that. 41 to the center of that circle, yeah. Now, that's 41 is half of the 82, so it'll actually be right on the top of this surface. Go ahead and grab that plane. You can see how it isn't quite symmetric, right? And I forgot to check the size we're dealing with, which is 16. 16 is the radius of this big piece, I think. Yeah, that's what that arrow looks like. 13 drills, 16 to the outer piece. All right, 16, and it's 41 on top. Let's go ahead and project that center line, that line. Then we're going to have a radius 16 circle. And that point are horizontal relative to each other. And you'll see that that sticks out. We need it, if we're going to extrude that circle, we need it to include those sort of vertical component, if you will. And so let's draw a point-to-point rectangle. Yeah, point-to-point rectangle. One of the points is on that line. It comes down like this. Point there, on there, tangent, or rather, that to there, tangent. No, doesn't like that requirement. Let's just make that point and that point. Point on line, point and point horizontal. That's good enough. And then this actually can kind of come down an arbitrary amount. So let's just grab a dimension it, sure, 24 sounds good. And now we need to trim up our lines. This line can become a construction geometry line. And then we will trim out this bottom part of the, one of the tools I'd like is trim to construction line. In other words, make the trim, just turn the line into construction instead of deleting it. That might be possible. All right, so that's it for that shape. Let's see, it's 29, 29 with 2 in the middle. So that's 60, symmetric, right? Add, symmetric, 60. There we go, yeah, dimension. And that looks pretty much like it. That looks good. All right, now let me say okay. And that's, I think that's pretty much it for our additive features. We need to drill a hole there, drill a hole here, and cut that slot. So let's start with drilling the hole. And we could probably drill the hole and cut the slot at the same time. So, and we can either pick this surface, right? Or instead of picking the surface, we pick the corresponding plane that cuts through the middle. And by referencing the origin planes, changing features doesn't change. So if we change the features of this previous extrude, then what will happen is this face will be renumbered and things won't fit the same. This has been mostly fixed in release 1, supposedly. Haven't gotten that far to using it. But by and large, I use the actual plane references. And if I need this face, I'll create a sketch reference to this plane and then offset it to that distance. That way I'm not dependent on the numbering of the face. So we'll go here. And we'll go ahead and project this circle. Then we'll make our interior circle, which I completely spaced what the size of was. It says 5398 to 5390. That's pretty specific. Let's just call it 54. Because it doesn't have to be all that exact for our purposes. So 54 on the diameter. Although I guess it could be exact. Make it 5390 plus 53.9, I should say. Might as well make it exact if we have the exactness to work with, right? And then at the same time, we need to cut this 2 mil slot in the middle here. So easiest to do that is a centered rectangle so that it ends up being 1 on each side. All right. So we'll pick this dimension. Say that's only 2. And then we have to do some trimming so that we have an actual singular object, if you will, or a singular profile for it to use as a cutting surface. So we will trim that spot, all these lines, so that now we have a singular profile surface, if you will, a singular wire, as they say. And then as far as this dimension, 34, make it 35. You see, we still have a couple of dimensions of freedom, and it's probably because, yeah, see, I can just move around like that, right? We lost our symmetry when we deleted the other line. But if we grab all 3 of those 2 spots in the line and say symmetric, oh, still thinks we have a degree of freedom. What's that degree of freedom? Oh. My symmetry constraint didn't work. That one, that one. Symmetric. Now you're over constrained. Why is that? Maybe we do that spot to this line, point to line, -1. There we go. Well, that did it. That got me all constrained without any headaches. All right, close. And then we say, or I say, make a hole. Make a hole through all, symmetric. And there's that feature. Now we've got one more hole feature to make through the middle there. So again, easier to make it on the origin planes. And it is concentric to this arc. So we can easily locate the hole. And it would help if we bothered to remember what the size of the hole was. 13. All right. So diameter 13. Close. Locket. Through all symmetric. All right. Now we've got it. Now we've got everything except for the fillets and rounds. And it says the fillets and rounds are all R3, except this one is kind of hard to see. It says R6 for this one. I think that's another R6. So it's R6 around the base. And I don't know if that's R6 up under here. Hard to say. Not specifically called out. So if it's not specifically called out, I'm going to go with the overall dimension. The comment here of overall. Most of them are R3. So we're going to start radiusing. And it's going to be 3. And we're going to select a bunch of extra edges. That one and that one. That one, that one. All these. Finally get the surface. There we go. Over here, get that edge. And then you notice we need this edge and this edge, this edge. All right, do we have all of them? I think we have all of them. I'm going to presume these under edges under the circle are also the 3. All right, I think that's it. They okay? And yay, they all worked. And the fillets all worked this time. A round of applause. All right, those are all the R3 fillets. And we had a R6 fillet around the base. There we go. One more over here. That's it. Okay. Those are R6s. There we are. That one actually worked out fine without any headaches. Love it when it comes together the first time, don't you? I don't think we're missing any feet. Oh, missing this 6 drill feature right here. That's easy enough to add. And it is right in the middle of that. So let's project that. What I wanted. Let's see. The whole thing. Interesting. All right. Find the halfway. So in this case, let's just draw a horizontal line here. We're going to make that a construction line. And let's see. Distance between these 2 points. should be, oh, that's right. And had to make it an exact number, right? Now it's a freaky number. Maybe let's make it, let's project this other line. Because the difference between here, this point, should be more rounded. Yes, it's 41. All right. So we can say this point is on this line. And then we can draw our circle, which is diameter 6. Close out. You can see our sketch in there hiding just a bit. Now if we pocket through all, it's going the wrong direction, so we'll say reversed. There we go. There's a complete drawing. Ain't that nice when it all comes together like that? I like that. Now, it looks a little bit askew, but like I said, I think these drawings were intentionally askew. You couldn't just use a ruler to measure off the drawing. Instead, you had to go by the exact dimensions. But that's a good one. Turned out better than that other one. That's for sure. Oh, I see. I'm still missing this fillet around here. And that was part of the 3 fillet. So let's select these parts here. Not you. All right. There we go. I knew it looked a little bit off. And we get some error messages that we can't read. Light theme on 21 is kind of busted. That is fixed in version 1. The reason there's so many fillets on this, because if you were making this out of a hunk of metal and you were subtractively doing it, you wouldn't want nearly any of these fillets. Oh, look at that. Oh. Actually, I forgot these fillets around here, didn't I? Yeah. Missed those fillets too. Boy, this got a little fillets. The reason it has a lot of fillets is normally this is actually a piece that would be sand casted, and then only the necessary spots would be machined, because cutting it out of one large piece of material down would be very wasteful, and making sharp corners in sand casted molds is difficult at best. So all these smooth surfaces, like the reamed inside hole and the face here and the slots, those are machined after the part is cast. So the fillets are actually there because of the necessity of sand casting, not because you would include that many fillets on a machined part, a wholly machined part. But like I said, looks like we're missing these edges as well. Select to add them. All right. Now we're pretty close to being done, I think. Let's just show where our pocket is. That's our completed piece. Got all the fillets now. Now the Too Tall Toby practice site has masses and everything. I don't know what this is supposed to be, a mass, but let's see. I got this little button I put up here as a macro. Oh, Sketch is complaining. Recompute failed. Bad constraints. Because, all right, well, delete that. Again, a renumbering problem or renaming problem that is supposed to be fixed in version 1. Let's reproject. Get our distance again. Back to 41. There we go. Everything looks green here. Locket, recompute. We're good. No, we're not good, because that fillet's busted now. Because these are no longer the same edges that they were before. There we go. That's better. So these are all of these. You make it a change in an earlier feature and it messed up a later feature. A lot of that has been addressed in release candidate 1. Or so they say. Said most of my practice has been in this release, so I've been continuing to use it. But as you can see, it's got its idiosyncrasies for sure. All right, now we have a good version of it. And let's see. Let's see if our printer is done yet. No, it looks like it's still printing because it's still got hotness going. All right, let's go ahead and save this guy off before we forget. Figure 1. Replace the earlier practice piece. And there we go. So, unfortunately, our printer doesn't tell us how much time it has left unless I go look in there. So if you want to hang around for that, you're welcome to. Let's see where our status is so far. I have 48 views here and there. That's not bad. Blue Knight retracted his message. That's okay. Glad that you came by and liked it a little bit, just for fun. All right, let's see what else we want to do here. Well, let's go check the printer and see how long it's got left. Be right back. All right, good timing. It looks like it only has a couple of minutes left. We can maybe think about doing one of the other diagrams. Probably take too long. We've already gone a while now. So let's see. What to do. Go ahead and close out of FreeCAD for now. We'll come back over to the main screen. There we are. And our part is almost finished printed being done, and it was printed upright, so I think it looks all around, it looks like a cleaner print so far. We just, whether or not it'll fit. And based off of the almost fit of the messed up part, I'm fairly confident it'll fit. At least the outer size seems about right. We'll have to get some super glue or something to that effect to get it attached. But should be done any minute now. And here I just dance around. Be sure to like and subscribe and ring the bell for notifications and all like that. And here in a minute we'll show you what we got done for the broken locket. Oh, there's the beep now. Hang on. Let's grab it. Alrighty. So here we go. Much cleaner looking, huh? The little brim here, we'll just take that off the bottom. And there's the little bit of support material in the middle. Pick that out with the sharp, pointy object. Just kind of clean it up inside. And there you go. Let's see. Moment of truth. Does it fit? Ooh, it's a nice fit too. Hey, always good to end on a positive note, eh? So we will glue that in place for her. Let's double check that we can fit the necklace through, which I'm pretty sure we can. Yep, no problem there. Now we just need to glue it, and we're good to go. Thanks, everybody. I should probably clean it up just a little bit. I got a few little plastic hairs here and there, but alrighty, that's it. We repaired the locket, and everything's looking good here. We even have a spare in case it fails somehow, and having that spare helped remove the concentrated heat from the top, so it's much cleaner. This has got enough beef to it around the edges. I don't think she's going to have problems with the layer separating. So, thanks again.